I'd like to start with some short introduction. My name is Alexey Tikhonov. I work as an IT programs director in ROSPHOTO. It's a Federal Museum of Photography in Russia. ROSPHOTO is not just a museum, it's only Federal Museum of Photography in Russia. That's why we are tasked with helping other museums with developing a strategy or methodology of preservation of photography and furthermore, preservation of digital photography. And that's why we became one of the leaders in digital preservation strategies in Russia. And what I want to talk about today is a multimedia that is produced by a museum. Not especially produced by a museum, but multimedia that is interpretative, that is using museum objects or objects from museum collection. And what to do with them after it was produced and after it ran its course. The problem is, the usual way of working with multimedia, or the common way, is that multimedia is separate from the museum collection, and it's often produced by different artists or companies by order from museum, and the finished product is quite a separate product from the collection itself. And we should think about how do we preserve this multimedia. Because multimedia is not just a fleeting way to enhance or enrich experience in many cases, because what we actually store as museum objects is not just physical objects, not objects themselves. We store experience and we preserve human experience. And that's why museums now are struggling with definitions of what museum is. And it's not just a place for storage, it's usually a place for transferring or giving access to different human experiences. And for many objects, even traditional objects, the multimedia is the only way to properly show the object is in function. Object as a functioning object. For example, even such simple object as book, especially illustrated book, usually we cannot give it to visitors, to hand them. We can store the book inside a glass case, and that's about it. We can open it on some pages. And that's why it cannot function as it was designed to function. You cannot read the book if you access only one page. Therefore, the only way to give access to the books in our collection would be to create a copy. And creating a physical copy is not always feasible or possible. And so we need to do some multimedia product. For example, we can scan or photograph all the pages and create some IIIF presentation of it and access it through a website or via some specialized installation, etc. And in these cases, the multimedia is the essential part of the collection itself, essential part because it's a presentation layer without which we cannot keep the object accessible, keep the object as experience, not just a dumb object like artifact and black box in itself. And therefore, it's paramount to be able to preserve multimedia interpretation. And what are the ways to keep multimedia from becoming obsolete and to keep it workable in the long term? We need to use technology that is open technology, common use technology, with lower risk for getting the obsolescence. We need to keep solid documentation, and not just documentation about how it was done, but the problem is we need to be able to recreate multimedia at some point in the future. And technology marches very fast, as we all know. So we need to create a functional testing documentation. So we need to know what our multimedia should do. We need to describe the experience that we want to achieve, not especially all the technological parts. And it helps if we divide our multimedia creation process into purely technological, exchangeable parts and parts that are essential for this specific multimedia. For example, if we show something on the screen, we don't know what screen we'll be using in a few years probably, and its resolution, etc. But we do know that we want to show picture to someone. So our description of this project will be that the person should see the picture, for example, in a best quality available at the moment, or as close in core information as it is to original object. And in some cases, we can even do a formal functional testing common to programming. If the multimedia is more complex than just some object showing something, and it has some programs or scripts in it, which is usually the case, we can describe it as a functional testing environment, as programmers do, and this testing will be a way to describe what experience we want to achieve. So if we will describe if person who is visiting or interacting with our multimedia does that, what is expected outcome? Because importance of it is that the content will be changed in some way. For example, if we show something now, some pictures even, and we have rescan them from an illustrated book or manuscript, and we have this kind of scanner that you have now. In 10 years, probably we'll have scanner that will be useful, that it's able to produce a resolution like 10 times what we have now. So we keep the description of the process that we want to show something, but the files themselves, they don't need to be in the part of multimedia. We just need to keep connection to them, to our collection, because we will use new files for new technology when we have. We should determine where we keep our data. Of course, when we create multimedia, we create derivatives. They could be quite specific to the installation, to the multimedia product. And some of them are different from the object themselves, different enough that we need to think about it, to interpret it. And that's what I call interpretative derivatives. So if we need to create something that is specific to this product and cannot be directly algorithmically created from the originals, then we should keep separate in some way in our repository or together with multimedia, as it's usually done. But sometimes we can just describe the rules for conversion. So if we need to just make a smaller resolution pictures from our collection, we don't need to store these smaller resolution pictures in our product. We can just describe that we need to the process of conversion. And this way we can always turn back to our original objects, and that helps. And that way we ease our migration process, because we store just the algorithms, we store the description of the multimedia, not all the parts, because the less working parts, programs or objects we store, the less chance of obsolescence or data loss is there, or data duplication. And therefore, there's another point that we should probably stick to. Keep connections to our originals, to our digital repository. And to, if possible, the multimedia objects or installations should always refer to originals, and they should be able to get the new data or new objects from repository when it's needed. And this way we get into another point, that we need to create some kind of modular technology to be able to preserve our multimedia objects for a long time. So we keep functional low-level technology process separate, that it's exchangeable, and it's should be described as a function, not especially kept in our repository and we keep only the data that it changed so much that it should be stored separately from our originals. For example, like new coloration or new crops or something that rewritten or etc. Not to give just description, I want to present a case. And the case was a multimedia installation that was part of the exhibition in our museum in ROSPHOTO last year. The exhibition was about photographs of the city from the end of the 19th and start of the 20th century. And there were several multimedia installations. Some of them simple, some of them more complex. And I want to describe them because we tried to do a test case of how it should be done to reingest or keep the multimedia easier to represent. We had the tools available because as a research facility, we've developed our own collection management system that is not just collection management system, it combines functions of a long-term preservation system, museum collection system, and digital asset management with a digital repository. And we don't just store them, our collection objects, but additional materials as well. For example, even information about multimedia systems, etc., or additional photography that we do, etc. It helps because we have a primary point of truth, so we can route all the data to the one point. And if we research something, we usually, if it's possible, we store it in the same place. And also, we decided to produce the multimedia for this exhibition ourselves, so we had complete control of the technology. So it wouldn't work for everyone, it wouldn't work for a complex project that the museum is not able to produce by itself, but if we don't know how to do something, we can just set the requirements for the project and to be able to store the results in multimedia later in our system. And so first decision was to use one technology stack for installation, so all the components will work in the same way and they can interact with each other and with our digital repository. In this case, it was a read-only, so we don't store anything in our main system, but we need to be able to read information. And some of it was done in real time, so we can access directly some parts of some derivatives from the original objects. And we used common and widely adopted technology for mostly it was a Python script for installations and for systems that needed more complex interactions between visitors and systems. We used web technology. That is, web technology is not the best in the sense that it changes quite often, and so backwards compatibility is sometimes a problem. But not the worst as well, because we have complete source, and for example, for Python script, it's so readable, so it's a kind of description, almost human readable description of the process itself. So you can convert it to just a human description. So this is how we get the data from our repository and how we display it. But it's also a functional program that works in a multimedia process. And some of the technology we used is interchangeable. So all the components interact via socket I/O protocol and could be changed to another without much difficulty. So we don't need to keep all the technology stack just to describe how they interact. And the simplest installation was exactly as was described before. We needed to show some picture books, like photo albums from 19th century. And they are quite fragile, so they are kept in a glass case, and we don't even want to put too much light into it because they are old and the paper gets to lose the photographic content, of course. And so there were several albums in a glass case and small microcomputer, Raspberry Pi, that was used to That's several buttons, and visitors can push the buttons, and when they put the button near the album, the light coming up, and the screen showed someone browsing through this album. Very simple. And in this case, we produced additional content. So we needed to produce this video of browsing through the album. We already had all the pictures scanned, so it's additional, not really needed to primary objects in the repository data, but it's quite useful. It could be reused for other objects, so we just keep them close or together with our primary objects in our repository, because it's another way to show them. So it's not specific to installation. And the computer just downloaded needed albums from the collection that we assigned to it and reacted on the button press. So it's quite simple. So what we needed to describe it's just the interaction with this person. So description was simple. People push the button, the light comes up, and the album is shown on the video screen from the specific collection. So description is quite simple. The program itself is stored as well as the object, but it's quite simple and can be changed. Many parts of it can be changed. And technology is not quite important, what model screen is or what light producer is. Of course, we know the amount of lumens that we are allowed to light on our album, but other than that, it's not so important. And we had a different installation, also not so difficult. We need to be able to show stereo photographs, and you cannot show stereo photographs without some kind of device. Well, you can, but it's difficult. No, not all people can unfocal them to be able to see 3D. So we had some physical stereoscopes to show the stereo photographs, but no, we had also glass stereo photographs, and some of them were just in electronic format. So we built an electronic stereoscope, also based on the same technology. That's Python script on Raspberry Pi and a small screen inside the stereo equipment. And what was different from the previous installation is that we, for every object, every stereo photographs, we've created some specially prepared file. We scanned or photographed the original and removed unnecessary parts. Sometimes we had to like nudge some left and right part to be able to recreate 3D effect more. And we decided to store this derivative also with originals, because stereo photographs cannot be presented without some kind of equipment, and if we change it or do something completely different or show them conversion to some common 3D format through web, etc., this file will be useful. The third installation was a little bit different. It was not just to show objects, it was to create an experience and to show them feeling, and it was more creative or more interpretive. The problem was there were very many architectural shots or streets of St. Petersburg, and St. Petersburg is very flat. We have no elevation in the city, almost no elevation, like 10 meters or something. And to get a good photo of city, you need some kind of vantage point. And in 19th century, people didn't have drones, so they usually used roofs or windows from apartments. And we wanted to show that to people. We wanted to be for people to give the feel of that. So we created installation that was like camera and a window. And so we used old camera, and we put some projector in that, and several screens together. They played the role of a window, and there was a control screen where you were able to choose the point of view and to see how it was done, like be a person in this room. quite bare bones, but I think it worked on some level. And there were several screens and the camera itself, and all of them had computer, also microcomputer that was used to work with it, and they interact via network protocol in itself. And so what we needed to achieve it? First, we needed to create the window from the original photographs. Because we had specific dimensions of the window, and we had different photographs. We needed to make them a little bit more realistic. We didn't go all the way. There was a plan to do a video, but anyway. So we used a crop and some digital enhancement to make them more real. And that was creative derivative. So it was something that couldn't be done automatically or algorithmically from original. And we decided to also keep it together with the original, but as a derivative. And because it was a little bit tied to, not quite exactly tied to dimensions, but tied to a crop, okay, we decided it was useful enough to keep them. And then every part of the installation, I mean camera and part of the window, had to get this part of the picture that it need to show. And that's also derivative, but that could be done algorithmically. So every script knew which part it needed. And so to summarize, multimedia, it won't replace all the objects, of course it shouldn't. But in some areas, it's as important to store true experience or to store the functional objects. And the only way we do it is sometimes the multimedia, and so we have to do it. And as our test case shows, it's not impossible. And if we keep the process planning, we start to plan early, as always, it could be easier. Thank you. That's all.